Hi students, so in this video we are going to review what we know about how to write lines in y-intercept form, and we're going to look at a few different examples. One's really easy to see, and then the other one is not so easy to see the way we've normally written it. And then we'll go into problems with transversals and maybe using some SOHCAHTOA, some sine, cosine, and tangent to solve for sides. And I don't think we're going to be solving for angles this time. So let's go ahead and get started. So in this first example, you have a line, and you're used to doing y equals mx plus b form, slope-intercept form. So what you have to do here is identify the y-intercept, which is where the line crosses the y-axis. And then you also have to know the slope, that's m. In this one, it's nice and easy to see. You can see the y-intercept, it crosses the y-axis at 2. So in this particular one, b is equal to 2, so we can write a 2 there, and it's a positive 2. And we can also find the slope by going from one point to the next, and we think rise over run. In this case, if you go from the left point to the right point, it's actually going to be falling. So it's going to go down 2 and right 1, 2, 3. So that's going to be negative 2 over 3. And then you write it as negative 2/3 x plus 2. So in this particular example, right, it's nice to see when you have it crossing through the y-axis and you can see a slope. It's very nice. In the ones that they give you, they're just trying to show you that you can also find it by using your slope and then plugging in a point, which I think we've done before, but we'll just review that again. So again, y equals mx plus b. This time, by looking at it, it's kind of hard to see, where it crosses the y-axis. It's somewhere way up here. And so what we're going to have to do is find a slope. We can actually do that by looking at the 2 points that they've given us here. They also gave us these two in your book. And so you can at least find the slope that way. And then we can also plug in one of the other points to find our y-intercept. So let's do that. So our slope. If we think about going, again, from left to right, from the left point to the right point, we have to go down. This up here is at 3, 6. That's where that is. And you can see in your book anyway, when you see this, you'll see that it crosses those grid lines at 3, 6. And then this is 4, 0. This one over here is 5, negative 6. So if we're trying to find the slope, we can see to go from here to here, we'd have to go down 6 and right 1. So that's going to be y equals negative 6 over 1, or negative 6, times x plus b. And again, we don't know what b is just by looking at this. So we're going to have to plug in a point into x and y, and that way we can solve for b. So again, the point that I mentioned here, this is 4, 0. So now we're going to plug in a 4 for the x and a 0 for the y. So we're going to say 0 equals negative 6 times 4 plus b. And from this point, we can solve this. So 0 equals negative 24 plus b. And then if I add 24 to both sides to get b by itself, I get 24 equals b. So now I'm able to write my line as y equals, and I've got my slope, negative 6x, and now I have b, so plus 24. So they're going to just give you some of these graphs that look a little different, than what you're used to seeing. And you'll have to plug in a point and use your slope to find the y-intercept. Now on to the next part. They talked about transversals in this next section. It says they're designed to give us practice both with right triangle trigonometry and with the relationship of the angles formed when transversals intercept parallel lines. So what do I mean by that? So example 1 in your book, it gives us this figure, and it shows basically two parallel lines. So we've got these two parallel lines, and then we have this transversal going through. And this transversal is creating this right triangle right here. So these two lines are parallel, okay? And they say, line 1, line 2. And they give us an angle of 153 degrees here. And here is the letter Z. That's a variable. That's an angle right there. They also give us an angle P. And then they ask us to find A and B, and they give us the hypotenuse of this triangle that's formed. So it asks for just A and B as the final answers. So what we do is remember, we want to find, we only have 153 here, so we need to find Z. So remember that these two angles add up to 180 degrees because they form a straight line. So we're going to do 180 minus 53, okay, and we're going to get 27. So that means that Z is equal to 27. So we can say this equals 27 degrees, right? And this is where you have to relate the parallel lines to this. So whenever you have parallel lines, then, and you have a transversal going through, then these are called corresponding angles. This one here and this one here. They're on the same side of the transversal and they're both above the parallel lines. So they're congruent. So that tells me that P is equal to 27. So if I know that P is equal to 27 degrees, now I can find A and B using some trigonometry. So what I'm going to do, again, let's write SOHCAHTOA. Anytime we're dealing with the trigonometry and we're trying to find sides or angles of a right triangle, let's write that. And then let's look at how A and B are related to this angle here and the 7. So if we look at, let's just say we want to solve for A first, just because it comes first in the alphabet. So if we want to solve for A first, we notice, according to our angle, we have the side that's adjacent to 27. And we have the hypotenuse. So look here, where do we have an A and an H? Right there. So cosine, we're actually going to use cosine for this. So we're going to say cosine of 27, because that's our angle that we're looking from. So cosine of 27 is equal to adjacent, which is A, little a, over 7, which is the hypotenuse. And then in order to find out what A is, multiply both sides by 7, and you'll have A. So if we look at what that is, we can do, on here, we'll do 7. I don't know if you can see that well. I'll try to angle it a little bit, but 7 cosine of 27. If I put that in the calculator, I get 6.23 or 6.24. So 6.24, A equals 6.24. And now we can do the sine. Okay? So we'll try to find B. And we're going to use sine because if you look at how B relates to angle P, it's opposite. It's opposite of angle P. So we're going to have to use O, and then we have the hypotenuse, H. So we have to say sine of 27, that's our angle, equals the opposite, so B over 7. And now, again, same as before, multiply both sides by 7. And when you do that, we're going to do 7 sine 27. And this is where we get 3.18 approximately. So B is 3.18. So that's how you do those. And that's all they wanted. They just wanted sides A and B. Final example on this particular lesson is example 2. And it's very similar. On this one, it shows two parallel lines. And again, it has a transversal going through. And it says lines 1 and 2 are parallel. The angle that they give you on this one is here. It's 158. They're looking for angle B, and you've got angle A you need, and I'll just again draw this little triangle that they give us. Here's 90. They say the hypotenuse is 90, and then you have M and N. So this is very similar to the one that we just did. So again, these two angles add up to 180. So think, okay, what's 180 minus 58? And that's going to be 22. So B is equal to 22 degrees. And that means, again, A is equal to 22 degrees because those are corresponding angles. So again, we're going to set these up very similarly. So we're going to say, let's say we're solving for M first. Again, you can do cosine of 22 because we're dealing with, or cosine of 22 is the adjacent side, that's M, over the hypotenuse. Okay, and then again, multiply both sides by 90. And then for the other one, we're going to say the sine of 22. And again, that is opposite over hypotenuse, so that's N over 90.